So, we have seen then this one, that both sides we are dividing it by that your rated capacity of area 1, it is in megawatt, right, PR1 is in megawatt, right. So, if you do so, then this will be in per unit. So, delta P ti 1 2 per unit is equal to T 1 2 delta delta 1 minus delta delta 2. This is equation 23. One thing before proceeding further, I would like to tell that hence onwards, I mean after this equation 23, again and again we will not write per unit PU. We will simply write delta P ti 1 2, but it is understandable that all these quantities are in per unit values. So, now T 1 2 actually is equal to magnitude V 1 magnitude V 2 cosine of delta 1 0 minus delta 2 0 divided by P r 1 x 1 2, right. So, where T 1 2 I have written here that magnitude V 1 magnitude V 2 cosine delta 1 0 minus delta 2 0 upon P r 1 into x 1 2. Now, the equation 23 can also be written as, that means this equation it can be written as your delta P ti 1 2 is equal to 2 pi T 1 2 and delta delta 1 and delta delta 2 can be written as your 2 pi then T 1 2 then integral of delta f 1 dt minus integral of delta f 2 dt. This is equation 24. How things are coming? In general, you know that delta dot is equal to omega. Here I have done it for you, is equal to 2 pi f. F is the nominal frequency 2 pi f, right. Now, therefore, say this is general thing delta dot. So, for delta 1, so delta 1 dot will be omega 1. That means, if I take small perturbation, then delta delta 1 dot will be delta omega 1 is equal to 2 pi, it will be your delta f 1. Therefore, delta that means if you integrate delta delta 1 will be 2 pi integral of delta f 1 dt. Similarly, here delta delta 2 will be 2 pi integral of delta f 2 dt. That is why in this equation that means delta delta 1 in this equation you substitute 2 pi integral of del f 1 dt, and here you substitute 2 pi integral of del f 2 dt, take 2 pi common. So, it will become 2 pi T 1 2. So, delta P ti 1 2 is equal to 2 pi T 1 2 integral of del f delta f 1 dt minus delta f 2 dt. This is equation 24, where delta f 1 and delta f 2 are frequency deviation in area 1 and area 2 respectively, if there is a change in the load in either of the areas or in both the areas, right. Therefore, similarly, power flowing from area 2 to area 1, this is I am not doing, from this inspection you can write power flowing from area 2 to area 1, that means from this side to that side. If you take here direction is showing that 1 to 2, that means if power flows in this direction from 2 to 1 in this direction, then you can directly write delta P ti 2 1 is equal to 2 pi T 1 to T 2 1 integral of del f 2 minus delta your integral of del f 1 dt, right. So, in this case it is 1 2, and in this case just interchange those suffix, it will be delta P ti 2 1, it will be 2 pi T 1 2, right, T 2 sorry 2 pi T 2 1, and it will become integral of del f 2 minus integral of del f 1 dt. So, just opposite to that. Therefore, delta P ti 2 1 is equal to 2 pi T 2 1 integral of del f 2 dt minus integral of del f 1 dt. Basically, if you look in the diagram, because line resistance is neglected, there is, so here if it is delta P ti 2 1 2 rather, and in this side if it is delta 2 1, then in real unit when it is in megawatt, basically delta P ti 1 2 is equal to minus of delta P ti 2 1, because loss is neglected. So, everywhere this deviation will remain same, we are not considering the power loss, right. Therefore, this equation similarly we can write, but where delta where T 2 1, this one V 2 V 1 same thing, cosine earlier it was cos minus theta cos theta, you know. So, earlier it was cosine delta 1 0 minus delta 2 0, now it is cosine delta 2 0 minus delta 1 0, same thing, divided by x 1 2, but it is in area 2, that is why divided by the rated capacity P r 2, right. So, this is your divided by P r 2, previous one that it was in area 1, that is why it was divided by your P r 1 both side. So, that means this is in per unit. I told you that I will not mention again and again, but this is in per unit delta. So, T21 is this one, right. Therefore, you divide equation 24 by equation 25, that means this is 24. So, divide equation 24 by equation 25, that means this one, So, if you do so, you will get delta p ti 1 2 upon delta p ti 2 1, you just do it, no, you will get it. It is nothing but minus p r 2 upon p r 1 is equal to, say we are writing 1 upon a 1 2, right. That means a 1 2 is equal to minus p r 1 upon p r 2, we call area capacity ratio, but minus sign is taken care of. If you do not take minus sign here, then it block diagram that will change with that minus a 1 2, right. Otherwise, if you take a 1 2 is equal to minus p r 1 upon p r 2, actually p r 1 upon p r 2 is area capacity ratio, but with this minus sign sometimes we call this is also area capacity ratio. So, this is actually, it is written 1 upon a 1 2. So, once it is done, that your what you call this ratio, therefore, your T delta p ti 2 1 is equal to a 1 2 into delta p ti 1 2. So, that is why this delta p ti 2 1 is equal to a 1 2 into delta p ti 1 2. In general, if you take in real unit, I mean in megawatt, forget about that. Suppose it is not a per unit values. So, if it is in megawatt, then if a 1 2 is minus 1 actually, because delta p ti 2 1 will be minus of delta p ti 1 2, because loss is neglected. So, at any point of the line, this power will remain same, because loss we have neglected. So, now with reference to equation 10, incremental power balance equation for area 1 can be written as, we have seen earlier, no, just have a look this one. Suppose you have a generator, generator is suppose giving power, say PG1, and this is your load, say it is we are writing your delta PL1, and generation power also change, say delta PG1, and this is the tie line connected that. So, this is your power, this is 1 and this side is 2. So, this is your delta P ti 1 2. Then what is the power balance equation here? Delta PG1 minus delta PL1 minus delta P ti 1 2 is equal to, during because of the load disturbance, there will be a transient imbalance between generation and load, hence the tie power also it will be affected. So, if you just write down the power balance equation, so delta Pg1 minus delta PL1 minus delta P ti 1 2 is same as before, 2H this area 1. So, we have taken H1 is the inertia constant, 2H1 upon F0, then d dt of delta F1 plus d1 F1. This capital F0 and small f0 superscript is this thing same. Similarly, the delta F1 capital delta capital F1 and delta small f1 they are same actually, right. So, this is the equation during transient imbalance. We will see later, but at steady state what will happen? This term will vanish, because a steady state derivative is 0, only this term will exist, that we will see later. So, therefore, during transient imbalance, delta Pg1 minus delta P, because at steady state if you write the equation as steady state, then delta Pg1 is equal to actually delta PL1 plus delta P ti 1 2, right. But if you take the difference, this is that, and this will happen during transient imbalance. So, it will be your 2H F0 d dt of delta F1, same thing we have seen for the single area system, detail have been given for the isolated case, plus d1 delta F1. This is for area 1, that is why you are putting delta F1 d1 H1 is the inertia constant. So, this is actually equation 27, right. So, next is that, so if you take the Laplace transform on both sides of this equation again and again, not putting delta Pg1s or delta P ti 1 2s, it is understandable. If you take the Laplace transform same as before and just simplify, right. So, what we will get? Delta F1 will get delta Pg1 minus delta PL1 minus delta P ti 1 2. We are not putting again and again all this thing in a function of s, because it is understandable, into Kp1 upon 1 plus Stp1. This is equation 28. Actually, for the isolated system, delta P ti was not there, rest was same. Here also delta P ti is there, that is why minus delta p ti 1 2 into the same thing. Earlier for isolated case it was Kp upon 1 plus Stp, now it is for area 1, that is why it is into Kp1 upon 1 plus St1, right. That means where Kp1 is equal to 1 upon d1, we know that Kp is equal to 1 upon d for isolated case we have seen. For area 1 Kp1 is equal to 1 upon d1. Similarly for isolated case we have seen 2h upon df0, it is for area 1, that is why Tp1 is equal to 2h1 upon d1f0, right. So, this is your what you call that equation related to delta f1, delta pg1, delta pl1 and delta p ti 1 2. This is equation 28 and these two we are marking as equation 29. So, this is understandable, right. You take the Laplace transform same as the isolated case, only one term added here, that is because the interconnection, that delta p ti 1 2, right. So, once this is done, just hold on. So, once this is done, then the block diagram for this thing, if you try to represent this your block diagram, this one. So, you can write this is delta Pg1, this is plus, right, delta Pg1 minus delta PL1 minus delta P ti 1 2. So, this is minus delta PL1 and this is it is coming from somewhere, we will see later, it is minus delta P ti 1 2, then into Kp1 upon 1 plus Stp1 and output is that delta F1. This is actually block diagram for area 1. This is actually only power, your what you call this power system part, right, power system and tie line part, and later we will later when this generation also later we will see from where it is coming when we will do for area 2. So, and the complete block diagram. So, this is this equation equation 28 actually is represented by this block diagram that is written here. That block diagram representation of equation 20 is given in figure 18. This is figure 18, right. Next is similarly for area 2, block diagram representation of area 2 is given in figure 19, this one. In the figure 2, what will happen that in area 2 it will be Kp2 upon 1 plus S2, delta Pg2 will be there minus delta P ti 1 2 and this is your minus A12 delta P ti 1 2. How things are coming here, right, this A12 because this is actually delta P ti 2 1. So, if you consider area 2, say this area, if you consider here, see here is I am simply making it here only. If this is your generator area 1, so this power due to change that delta Pg2 and this is your delta PL2, right, and this side is delta P ti 1 2 and this direction if you make it is delta P ti 2 1, loss is neglected. That means power balance equation actually same way we will get delta Pg2 minus delta PL2 minus your delta P ti 2 1 is equal to your this equation you will get that if power during power imbalance, that is this one you can write like this, that is your 2 H2 divided by your F0 into d dt of your delta F2 plus d2 into delta F2, right. And another thing is that as we have seen that delta P ti 2 1 is equal to A1 to delta P ti or what you call 1 2. So, here if you substitute this one, then it will become delta Pg2 minus delta PL2 minus A12 then delta P ti 1 2, because delta P ti 2 1 is equal to A12 delta P ti 1 2, right, from equation 26 is equal to the same thing 2H2 upon F0 is the nominal system frequency, then d dt, then delta F2 plus d2 delta F2, right. So, this is for area 2, this is for area 2. Now, if you again take the Laplace transform, you will get the your what you call the same thing, only the delta P ti that instead of your Kp1 Tp1 it will be your Kp2 upon Tp2 1 plus Stp2 and this is actually delta P ti 2 1, that is actually is equal to A12 into delta P ti 1 2, right, that we have seen. That is why it is coming, it block diagram is made like this, and A12 is equal to minus PR1 upon PR2. So, that is why it is written here. So, and this is delta Pg2 and this is minus delta P2. So, this is Kp2 upon 1 plus Stp2, that is delta F2. This is actually figure 19, this is block diagram portion of area 2. So, this is power system, this is tie power, we will see from where it is coming, and this is delta Pg2 and this is minus delta your minus delta P2, right. So, in this case there is your what you call that next we have to complete the block diagram. So, what we will do from that from equation 24, right, from this equation 24 if you come to this, right, or I am writing like this, that equation 24 was written like this, no, rather than searching I am writing here that delta P tie 1 2 is equal to 2 pi T 1 2, right, in bracket it was integral of del f1 dt minus integral of del f2 dt, right. So, if you take the Laplace transform, then it will be delta P tie 1 2, yes I am not putting in bracket, it is understandable, right, is equal to 2 pi T 1 2, right. So, this one in the bracket if you take the Laplace transform, it will be del f1 upon s minus del f2 upon s, right. It is actually del f1 function of s, del f2 actually function of s, but not putting. So, that means this will be equal to 2 pi T 1 2 upon s, right, in bracket it will be del f1 minus del f2, right. That means that tie line power equation also can be represented in terms of Laplace transform, right. So, that is why we are writing delta P, that is taking the this was actually your equation 24, this was actually equation 24, just previously we have seen. So, delta P tie 1 2 we can write 2 pi T 1 2 delta f1 minus 2 pi T 1 2 upon s delta f1 minus delta f2, this is equation 30. If for this equation block diagram if you make, then this is delta P tie 1 2 is equal to 2 pi T 1 2 upon s into delta f1 minus delta f2. This is the block diagram representation of the tie line. That means the tie line also can be modeled in the s domain, right. So, this is the tie line power equation. So, now if you complete the block diagram now, that means this delta P tie 1 2 whatever we have seen in the previous block diagram, this delta P tie 1 2, right, actually this is your delta P tie 1 2, this is delta P tie 1 2, here also delta P tie 1 2, right, and this delta P tie 1 2 you have to connect from here from this equation, from this delta P tie 1 to here. Now, if you make the complete block diagram of two area system, right, then it will be like this. So, if you look into this, then this is your area 1, this is the control signal U1, this is for isolated system you have seen delta this delta f was coming to 1 upon r, then minus feedback here, right, but here it is area 1. So, delta f1 is coming here 1 upon r, this is for non-reheat turbine only, right, because if I try to put one more block for reheat I cannot accommodate here, and this is your 1 upon 1 plus STT1, this is delta Pg1, and this is your disturbance 1, this is Kp1 upon 1 plus STP1, this is delta F1. Similarly, here it is U2 the control signal, this is delta F2, it is 1 upon R2, 1 upon 1 plus STG2, 1 upon 1 plus STT2, this is delta Pg2, this is disturbance minus delta P2, and this is delta F2. So, just now we have seen no delta P tie 1 2 is equal to 2 pi T 1 2 upon s delta F1 minus delta F2, this one we have seen no delta P tie 1 2 is equal to this one. So, this is the block, this is the block. So, delta P tie 1 2 is equal to 2 pi T 1 2 upon s delta F1 minus delta F2. So, this delta we have seen no delta Pg1 minus delta P1 minus delta P tie 1 2, right, your whatever we have seen into Kp1 upon s plus Tp1 delta F1. Similarly, here also we have seen no this is delta P tie 1, this is also we have seen no that previous block diagram, that this is a modeling actually, this block diagram we have seen no this one, same thing we are, same thing it is here also, here also same thing here also. So, this is delta P tie 1 2, but delta P tie 2 1 is equal to A1 2 delta P tie 1 2, right. So, it is minus, so delta Pg2 minus delta, and this is Kp2 upon 1 plus S2, and this is your delta F2, right. So, this is a two area interconnected system block diagram, assuming that in each area there is one unit. If you have more unit like composite modeling, then you have to put so many, but for the classroom purpose I think I for the classroom purpose this is okay, right. So, this is control signal, later we will see that. Now, question is that we have to put them in the state variable form, that is x dot is equal to a x plus b u plus gamma p. Now, I have written everything, all these things for you, but let me write down all the, and another thing is that the state variable is marked, it is arbitrary. Actually, whatever you want, it is arbitrary, it does not matter, result will remain same. But here frequency is x 1, that is delta f 1, that is why I have made x 1, because our interest will be generally frequencies and type power, right, I mean generation also. So, that is why the delta f 1 is marked as x 1, delta f 2 is given as a state variable x 2, and type power it is given state variable x 3. This way I have written generation 1, that is written as x 4, and generation 2 written as x 5, and here it is x 6 is delta u 1 and x your just governor output, right, something, and it this is these are the quantity not directly measurable, and this is your delta E 2 is given x 7. So, system is actually there are, and if you look into that, there are two disturbance your elements are there, delta P L 1 and delta P L 2, and two control signals are there, U 1 and U 2, and there are 7 such blocks are there representing your Laplace transform, your S represent term S. That means, this system order is 7 into A matrix will be 7 into 7, and two U's are there, U 1 and U 2, two control signals are there. That means, B matrix will be 7 into 2, and disturbance 1 delta P L 1 and delta P L 2. So, disturbance matrix will be 7 into 2. So, when we will write this equation, just I am writing for all of you this thing, first you take the x 1, right. So, if you take all everything is written here, but I will show you how we are making it. So, if you take the x 1 first, this one first, then it will be I am making it here, when you will I am making from here only, when you will see this recording thing, you will just write down on your notebook first this one and then make one by one, right. So, when we write x 1, look, x 1 is equal to, right, it is k p 1 upon 1 plus s t p 1, right, then in bracket it will be x 4, right, it will be x 4. So, it is x 4, then minus this is actually x 3. So, this is also x 3. So, minus x 3, right, and this is minus delta P L 1, this is delta P L 1. So, x 4 is equal to k p 1 into 1 plus s t p 1, then your x 4 minus x 3 minus delta P L 1. That means, if you go for cross multiplication, then it is x 1 plus s x 1 into T p 1 is equal to this x 3 I am writing first, minus k p 1 into x 3 plus k p 1 into x 4, right, minus k p 1 into delta P L 1, right. That means, this S x 1 is actually x 1 dot, assuming all initial conditions are 0, x 1 dot T p, this x 1 is going to the right hand side, minus x 1 minus k p 1 x 3, right, then your plus k p 1 into x 4 minus k p 1 into delta P L 1. That means, your x 1 dot is equal to minus 1 upon, it is T p 1, 1 upon T p 1, then x 1 minus your k p 1 upon T p 1, this is x 3, plus k p 1 upon T p 1 x 4, right, minus k p 1 upon T p 1 delta P L 1. So, this is that your first equation x 1 dot is equal to. So, x 1 term is there, x 3 is there, x 4 is there, other state variables are not there, and delta P L 1 is there. That means, in this equation if you see that x 1 dot is equal to minus 1 upon T p 1 into x 1, it is minus 1 upon T p 1 into x 1, then x 2 is not there. So, it is 0, then minus k p 1 upon T p 1 into x 3 minus k p 1 upon T p 1 into x 3, right, plus your k p 1 T p 1 into x 4 plus k p 1 T p 1 into x 4, right. no other x are involved. So, all 0 0 0, then it is the disturbance matrix first element minus Kp1 upon your minus Kp1 upon Tp1 into delta PL1, it is in the next page, right. U is not involved. So, U is not involved. So, here first row it is 0 0 and it is first one is delta PL1 minus Kp1 Tp1 first equation into delta PL1, second is not there. So, it is 0, this is first equation, right. So, similarly if you take the your what you call second one such that you will not be or what you call you will not be confused with anything, you can easily make it of your own. Now, second one what we will do, if you look into that this equation, then we can write x2 is equal to Kp2 upon 1 plus STP2 in bracket, then it is x5, right. So, this is x5, then minus, now this is x3. So, here delta p tie 1 2 will be actually a12 into x3, because this is x3 into a12, here it is a12 x3, that is delta p tie to 1. So, minus your a12 into x3 this one, right. Then disturbance is there delta PL2 minus delta PL2. Now, if you go for cross multiplication, it is x2 plus sx2 Tp2 is equal to Kp2 x5 minus a12 x3 minus delta PL2, right. That means sx2 is x2 dot. So, x2 dot Tp2, this x2 taking this side minus x2, then this is writing first x3 a12 x3, then plus Kp2 x5 minus delta PL2. That means x2 dot is equal to minus 1 upon Tp2 x2 minus a12 upon Tp2 x3 plus Kp2 upon Tp2 x5 minus 1 upon Tp2 delta P1, sorry, here that multiplication of Kp2 I have missed it, here it should be Kp2, right. Multiplication here also it will be your multiply by Kp2, here also it will be multiply by Kp2, I have missed it. That means, here it will be Kp2 into a12, right, and here also it will be Kp2 the Kp2 into x5, right, minus your a12 Kp2 into x3 minus, here I have also missed it, it will be Kp2 into delta PL2, right. So, this one also Kp2 into delta. So, rewriting in a phrase once again, x2 is equal to minus 1 upon Tp2 x2 minus Kp2 a12 upon Tp2 x3, right, then plus Kp2 upon Tp2 x5 minus Kp2 upon Tp2 delta PL2, right. So, this is the equation, right. Here actually at the time of multiplication I have missed this one, right. So, question is that now this is the, now you check this equation 2 you check. So, there is no in this equation, if you look into that, here no x1 is involved. So, second equation is 0. Next is minus 1 upon Tp2 x2. So, minus 1 upon Tp2, then x3, if you look minus a12 Kp2 upon Tp2 minus a12 Kp2 upon Tp2, x4 is not there, 0, x5 is there, x5 is this one, right, Kp2 upon Tp2, right, and then your this then other state variables are not there. So, it is 0 0, and if you go to the then no u is involved, only the disturbance in area 2 is involved, no u is involved here, therefore, it is 0 0, and here it is 0, and it is minus Kp2 into by Tp2 into delta PL2. So, this is the second equation. Thank you, we will be